All right, you guys. Sorry, I didn't see that I was recording. So what do we have here? We have a compound inequality. And I kind of want to show you guys what this looks like. What this is saying is that if I take the line 4x plus 1, I want to know what can x be that makes this line greater than or equal to 17? And what can x be that would make this line less than 12? So I graphed it on Desmos for you guys. The red line is 4x plus 1, is the graph of the function 4x plus 1. The blue line is y equals 17, and the green line is y equals 12, okay? So I want to know, where is this line less than 12, which is going to be below here, and where is this line greater than 17, which is everything above. So you can obviously see when x is equal to 4, it's 17, and then the higher I get, the higher x is going to get. So 5 and 21, I think, is another point up here. So x can be 4, or it can be any number greater than 4. And to be below the green line, x can be 2.75, or it can be any number less than 2.75. Okay? So how do we get that answer algebraically? What that looks like is you just have these two separate ones. You can do them all at the same time, right? So if we, this has got to be greater than that and less than this. Okay, let's split this up. So we have 17 is less than or equal to 4x plus 1. This is going to tell us what can x be that makes it less than or equal to 17. And we'll split it up here, and what this equation is going to tell us is what can x be to make this line less than 12. So it's easier to separate them out. You can do them all at once, but the answer gets a little bit confusing. So subtracting 1, divide both sides by 4, we get x must be greater than or equal to 4. On this side, we subtract 1, we get 4x less than 11, we divide by 4, x also must be less than 2.75, or 2 3/4. What does that look like in interval notation? What that looks like is x must be less than 2.75. So we're going to start off with that because that's the lower value. So x must be less than 2.75, but it can go all the way down to negative infinity, right? And then it can come all the way up to positive 2.75, but it cannot be that, right? Or union, it could be, we can also read this as the or sign. It can also be 4, but you guys, it can actually be 4, so we will do this, 4, comma, and then anything up to positive infinity. So what this part here is that middle part of the line that we saw in between the green and the blue line. All right, solve the rational inequality. So again, I'm going to graph this for you so you can see what it looks like. All right, you guys, so when I graphed number 14, this is what we get. And if you had me last year, I think we did a bunch of this actually on Desmos last year where we were making these graphs. So you can see we have a vertical asymptote here at 2, because if x was 2, it blows up the whole equation. It makes the denominator 0. And what we're looking for is, where is this function going to be greater than 0? So when x is negative 1, it's at 0. That's okay. And then it's above 0 as it gets smaller. But when x is anything above negative 1 here, okay, it's a negative number, so it's below 0. But over here, it picks up again, and it's going to be above 0 forever. So how do we figure that out without graphing that? How do we figure that out algebraically? So you set it up. Here's the equation. You have to find the zeros of the numerator, which we did. We have negative 1. If I make the numerator negative 1, I get 0. If I make x negative 1 in the numerator, I get 0. And the 0 of the denominator, if I make it positive 2, I also get 0, which is that vertical asymptote. Okay, so you find those zeros, and then you kind of make a number line. And this is fun, and you actually use this a lot in calculus. And you plot these numbers. So let's say negative 1 is here. Let's say positive 2 is here. and you're going to put these into intervals. Okay? And then you're going to pick numbers from each interval. So here's interval 1, here's interval 2, here's interval 3. And you want to pick kind of good, easy numbers to use. So if I pick a number smaller than -1, let's say -2, and I put it back into the equation, I would get -2 plus 1 on the numerator, -2 minus 2 on the denominator. I would get -1 over -4, which is actually a positive 1/4. So in this interval, we're going to have something positive, which means it is true, it is greater than or equal to 0. Okay, and then we're going to pick something from here, and probably the easiest thing to choose would be 0, although there are times where choosing 0 is a dumb idea because funny things happen with 0 sometimes, but we're going to use 0 this time. So on the numerator, we are going to have 0 plus 1. On the denominator, we are going to have 0 minus 2. Our answer here is going to be -1/2. So this one is negative. So this does not meet our criteria. Here, the function is less than, right? F of x is less than 0, negative there. Then let's pick something greater than 2. Let's just do +3. Put that back in. Our numerator is going to be 3 plus 1. Our denominator is going to be 3 minus 2. Our answer is going to be 4 over 1, or just +4. So here again, it is true, just like we saw in the graph, you get something positive, or f of x is greater than or equal to 0. So what we saw is true. X can be something less than -1, and it's bigger than 0. Or it can be bigger than +2, but it can't be +2 because that's an asymptote, but it can't be anything in the middle. So in interval notation, it's going to be -∞ to -1, and it can absolutely be -1. Union, starting at 2, but it can't be 2, all the way to +∞. That's so cool, don't you think? Let's try the other one. 1 over, and we're going to have to factor that denominator. Let's see, x, two numbers that multiply to be -18. Let's do 6 and 3, negative x, so we're going to have x minus 6 times x plus 3. I think that will work. Less than or equal to 0. Whoops. 0. All right, so in this one, we're just going to have zeros on the denominator, right? So our first 0 is +6. Our second 0 is -3. All right, and let's plot those on our number line. +6, -3. All right, so, and do not forget, it's not going to be either one of these numbers, and we are trying to find this time where it is negative. So let's take something here, -4, and put that in and see what we get. If I put -4 in, I get, all I really care about, I know my numerator is going to stay positive, so all I really care about is my denominator going to be positive or negative, because that's what's going to change this. X minus 6, so 4 minus 6 is -2. -4 minus 6, I'm sorry, you guys. -4 minus 6 is going to be -10 times. -4 plus 3 is still going to be -1, and that makes the whole thing positive because it's going to be +1 over +10. So this does not meet our criteria because this is going to be, f of x is going to be greater than 0. So let's try 0. And that's going to give us 1, +1 over -6 times +3, which is going to give me a negative denominator. So this is going to be less than 0. There. And then over here, let's try just 7. And that's going to give us a +1 over 7 minus 6 is positive 1. 7 plus 3 is 10. So that's going to be positive 1/10. Cool. So here, this is not going to work for us because this is also going to be greater than 0. So we're going to have positive here, negative here, but the negative is what we want. So our interval notation is going to be the lowest number x can be is -3, although it can't actually be -3 because that's going to be an asymptote. So we have -3, comma, and x can go all the way up to 6, but it cannot be 6 because that again is an asymptote. So this is going to be, that's where f of x is going to be less than or equal to 0. Let's check with a graph. Guys, as we can see in the middle, this graph is less than 0, almost 0, but still less than 0 here. Below, it's greater than 0. Over here, above 6, it's greater than 0. But we were trying to figure out where is it less than 0. So we have got that answer. I'm going to start a new video with the rest because that is going to be different information.